Okay, so good afternoon, everyone. I hope that we still are not sleepy. So today, I'm a representative from the CMKL University, which is a newly established university in Thailand. We're going to celebrate like 10 years next year. So our university only have one department, which is about AI and computer engineering. So of course, we are not expert in weather, climates, or those kind of earth science related fields, but our students actually have like strong interest in this kind of research theme. So yes, today we will talk about three themes that are being conducted in our university. By the way, all of them are being done by bachelor students, either second years of bachelor or third year of bachelor. So first will be about PM 2.5, which is one of the major problems, especially in the northern part of Thailand. And then we would like to talk about water qualities in the coastal area of Bangkok or Krachao. And the last one we would like to discuss about the street level flood warning for especially for Bangkok Metropolitan Area. So yeah, let's talk about our first theme. So of course, here we apply agentic AI. Of course, it's a four separated research, four systems, but all of them together we orchestrated to get some meaningful output out of it. And second would be about urban water sensing platform. So yes, of course, this will utilize the Sentinel-1 and Sentinel-2 satellite images, and then they are going to perform some kind of noise reductions and those kind of things. And of course, for the third one, since Bangkok, and as you already know that we have like 50 of the agencies that having data. So the last project will be focusing on the data that is available from Bangkok Metropolitan Administrations. Okay, let's get started. So for the first system, of course, we found that if we want to achieve something meaningful, we have to look at the data first, right? And we found that even though we have some stations to monitor PM 2.5 in the northern part of our countries, only 47% of the data is actually available. So in order to perform the next step in the pipeline, like forecasting or even trying to detect the source of the PM 2.5, we have to perform some kind of gap filling of the data. So of course, if it's just 1 hour of missing data, you can just perform things like interpolations and things like that. But for some reason, we also have problem that it's just missing for 24 hours or even days because, of course, some of them are in the remote area. So if there's some problem, it's like it will not have those kind of data. Of course, after we did that, we also perform things like PM 2.5 forecasting. Of course, since we mentioned so AI, right? But in fact, this thing is about machine learning. So we use things like support vector regressions with the integrations of convolutional neural network. Of course, there's lots of stuff try to predicting the PM 2.5, and then of course, if we already know the PM 2.5, right, we would like to also know where this comes from. So yes, of course, we use like neural network and those kind of things. So since time is quite limited, let's go to the next one. Okay, so of course, if you're living close to coastal area, of course, Bangkok itself, people might not know that we also have a connection to the Gulf of Thailand, right? So, of course, a few people who live in, let's say, the Bangkok Metropolitan Area, or if you have chance to see the satellite images, you will know that we have like this kind of area that look like a lung. So we call it Bangkok green lungs. So the people who live in that area, they are still heavily relies on the agricultural, and of course, if they have like salinity problems, let's say maybe sometimes the sea is rising, but there's not enough water flowing from the north, there might be some kind of problem with their vegetations. Of course, this is tree system. So of course, you can monitor the real data, and of course you can do some kind of predictions. And yes, they found some kind of interesting correlations here that they have like a negative correlations of from the satellite information with the actual water level. Okay, and the last system, of course, this is like one of the group that being under supervised by me. So they are second year student. They just found that the problem is that we actually have lots of data available, right? We even have canal water level. Some of the street also have like a water sensor so that they can provide what is the actual water level on the street. But yes, of course, we also have a public radar that people can just go and watch like what is the current cloud coverage or things like that. But of course, how to make it useful for the people, like the people in Bangkok, which is consisting of Bangkok itself and the surroundings provinces. So they come up with a proposal that is it possible to we try to create like a chatbot system that people can just ask for information. For example, this is like one analogy is that when I present about this project, we mentioned that. Let's say that if I have to travel from point A to point B in Bangkok, if you have ever been to Bangkok, it's actually a very big city, right? And we have lots of problems about rain bombs and those kind of things, which sometimes can flood the street. So if I want to plan my commute intelligently, I have to maybe gather information from various sources, right? For example, predictions, nowcasting, winds, or whatsoever. So how about we can just actually ask into this kind of system and it provide us back the information that is necessary for the people who have to commute. So okay, that's all from my presentations. Thank you for listening. And by the way, this is again it's all the student project. Thank you.